So what we're going to be doing today is 4-4. We're going to graph the sequence on the coordinate plane from an explicit formula. We're going to do both arithmetic and geometric ones today. So the problem says triplets seem to run in the Tribbiani family. Great grandma Tribbiani is a set of triplets. She had a set of triplets, and each of them had a set of triplets. The sequence shows the number of descendants in the Tribbiani family over several generations if this trend continues. So the sequence that we have is 1, 3, 9, 27. So the first thing that we need to do is figure out whether it's arithmetic or geometric. All right, this is clearly geometric. All right, what are we doing each time? Because I know it's not arithmetic because I'm not adding by the same number each time. So it's geometric. So what are we multiplying by each time? Well, to get from 1 to 3 to 9 to 27, we are multiplying by 3 each time. That means our R value, our common ratio, is 3. So remember, if you can't figure out the common ratio, you could just divide going backwards. 27 divided by 9, or 9 divided by 3, or 3 divided by 1. I'll give you a common ratio of 3. Writing the explicit formula. So the explicit formula is G sub n, the term that you want, equals the first term, so the first term being 1, times your R value, which is 3, to the n minus 1 power. So it says use the explicit formula to predict the number of descendants after 20 generations. So we want G sub 20 equals 1 times 3 to the 20 minus 1 power. So if I go to type that into my calculator, I have 1 times 3, caret button, 20 minus 1. Hit enter. I get a really, really big number. That number is 1 billion, all right, 162,261,467. So that is a really, really, really big number. And that happens in geometric sequences a lot. What you're going to do today that is new is this. This is what all of your homework questions look like. You are going to have to create a table of values using the first 10 terms of the sequence. Now, sequences always start with 1. All right, you're never going to start with 0. All right, whenever we're talking about sequences start with 1. All right, they always start with 1. All right, you're going to ignore the 0 value on the calculator when we go to do this. So create a table of values for the first 10 sequences. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So to get these values, what we're going to do is we need to type them into our y equals. So if we go to y equals, we're going to type in our explicit formula. All right, we're going to type in our explicit formula. So we're going to type in 1 times 3, caret button, x minus 1. Remember, we can't use an n, we have to use the x. So you're going to type that explicit formula into your y equals. We're not going to hit graph. All right, what we're going to do is we are going to use the table feature. So second and table. Now, like I said, sequences start with 1. Your table, when you use it on your calculator, starts with 0. We don't care about the 0, all right? We care about the 1. So all you're going to do is take your values from here and copy them into your table. So 1 is 1, 2 is 3, 3 is 9, and then we have 27, 81, 243, 729, 2,187, 6,561, 19,683. So now what we're going to do is you're going to have to graph them. All right. When you go to graph them, remember your first number is your x value. Your second number is your y value. So your term number, when you go to graph it, is how many we go over. And then your other value is how many we go up or down. Up if it's positive, down if it's negative. So 1, 1, over to 1, up to 1. It's going to be right on that black line. Notice that each of our squares going up here is worth 1,000. So if we're graphing 1, you can't tell the difference between 1, 3, 9. I'm trying to do these as big as I can. It's hard. All right. 1, 3, 9, 27. You still can't tell the difference. 81. You still can't tell the difference. 243 might be a little bit higher for 6. And then you have 729. That one you can definitely tell a little bit higher. And then 2,187. That's going to be right about there. And then this is really hard to do on this board. 6,596. So go up to 6,500. That's going to be right in the middle, right about here. And then we have 19,600 for 10. 19,000. That's going to be all the way up here. So you can see how it is exponentially getting bigger and bigger and bigger each time. This is not there. Sorry, that's not there. So it's getting bigger and bigger and bigger each time. With all of these graphs, you are not connecting the dots. All of these are discrete graphs. So you are not connecting the dots in any of these. All sequences are discrete. So all of these are going to be discrete graphs. We do not connect the dots. But this is clearly a geometric sequence because all of a sudden it is getting higher and higher and higher. It's not going up by the same thing each time. So take a look at the next one. In the next one, this time we are given the formula already. We're given the explicit formula. This is for an arithmetic sequence. A sub n equals 5 plus 2 times n minus 1. What type of sequence is this? This is arithmetic. All right, you know that it's arithmetic because it has the a sub n. What is a sub 1? Well, the a sub 1 is the first term in your sequence. So that would be the 5 in our explicit formula. The d is the number that, the common difference, is the number in front of the parentheses. So that is 2. We're talking about arithmetic sequences. So how do arithmetic sequences graph? Well, let's see how they graph. So let's go to our y equals. We're going to clear out that previous question. We're going to type in our explicit formula. So 5 plus 2 parentheses x minus 1. Close your parentheses. So that's what we're typing in. We're going to hit second and table. Again, remember we're ignoring the 0. So we have 5, we have 5, 7, 9, 11, 13, 15, 17, 19, 21, and 23. You can find them all by hand. The easier way is to use the table. It's a lot quicker. All right, so let's graph these. Remember, this is your x value. So this is how many we're going over. This is how many we're going up. So we're going over to 1 up to 5, over to 2 up to 7, over to 3 up to 9, over to 4 up to 11, over to 5 up to 13, over to 6 up to 15, over to 7 up to 17, over to 8 up to 19, over to 9 up to 21, and over to 10 up to 23. So if you look at that, I did a pretty decent job. All right. How do arithmetic sequences graph? Arithmetic sequences always graph as a straight line. All right. Arithmetic sequences always graph as a straight line. Why do they graph as a straight line? Well, what are we doing going from term to term to term to term to term to term? We are going to be increasing or decreasing, because these can go down as well, by the same number each time. So we are increasing or decreasing by the same number each time. Because we're doing that, that's going to form this straight line going up. Remember, we don't connect the dots. All of these sequence graphs are discrete, so we're not connecting the dots, but it's going up in a straight line because we are adding by 2 each time in our sequence. Take a look at the geometric one. So this time we're given the geometric explicit formula. G sub n equals 1 times 2 to the n minus 1 power. We know that this is geometric. What is G sub 1? Well, it's 1. What is your R value? That is your common ratio is 2. So how do geometric sequences graph? We need to go back to y equals. Clear out what's there. We need to type in our geometric sequence. So 1 times 2 caret button x minus 1. Go to our table, second and table. Remember, we ignore the 0 that's there. 1 is 1, and then we have 2 and 4 and 8, 16, 32, because we're multiplying by 2 each time, 64, 128, 256, and 512. So when you go to graph it, now notice that our graph, we're counting by hundreds. So all of these first ones are just going to look the same because you can't really tell the difference between any of those. 5 is 16. That one's going to be a little tiny bit higher, but not much. 6 is 32. Again, a little bit higher, but not much. 7 is 64. That's going to be a little bit more than halfway up. 8 and 128. So that's about a quarter of the way after the 100. 9 and 256. That's about halfway between 200 and 300. 10 and 512. So that's going to be right down in there. So notice what's happening with our geometric sequence. Our geometric sequence is all of a sudden being curved, all right? Where arithmetic sequences graph in a straight line. A geometric sequence is curved. It is really an exponential curve, all right? It's really an exponentially curved. Because it all of a sudden starts going up, 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 up really, really quickly. These could go down, 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 down. They could form a pattern like this going down also. All right, they could form a pattern like that going down also. It would be dotted though. I just did that so that you could see it a little bit better. So they're either going to go up like this or they're going to go down like this. When we take a look at arithmetic ones, they're either going to be a straight line going up like this or a straight line going down. Again, they're going to be dotted because they're going to be discrete. I just did that so that you could see it a little bit better. So go ahead and try this one, please. All right, this is our last example. Go ahead and try this one, please. Try typing it into the calculator, finding your values, and then try just to sketch that graph. I'm going to give you about 2 minutes to try this one on your own, please. Give you about 30 more seconds or so. So I already went and typed this one into the calculator exactly how it looks. 30 plus parentheses -5 parentheses x minus 1. So when we go to our table, second and table, remember we ignore the zero value. Be very careful because it's very easy to make a mistake where you just go, okay, the first one's 35 and write in 35 for 1. So be very careful when you're copying over the table. So we start with 30. We have 30, 25, 20, 15, 10, 5, 0, -5, -10, and -15. So when we go to graph it, we just leave the 0 column blank. 1 is 30, 2 is 25, 3 is 20, 4 is 15, 5 is 10, 6 is 5, 7 is 0, 8 is -5, 9 is -10, 10 is -15. So again, this was an arithmetic sequence. Because it's arithmetic, it is graphing in a straight line. This one is going down, obviously, right? Because our values are decreasing. We're going down by 5 each time, so it forms a straight line. So remember, geometric are going to be exponentially curved, and arithmetic are going to graph as straight lines.